Okay, so SST is y minus y bar squared, summed, of course. Now there is a easier formula, computational formula, that is called, which is given by this. So which is, you take sum of y squared. Okay, sum of y squared is right here, minus, okay, sum of y squared over n. So you have sum of y is here, square that and divide by sample size n. So this is that formula. So that gives us SST. That's the estimate of the total variation present in y values, and n minus 1 is the degrees of freedom for that, which is n minus 1, like that. Now SSR is y hat minus y bar squared. Again we have a simpler computation formula for that, which is you take b sub 1 and multiply by SSXY. So b sub 1, we already computed b sub 1 right there. You multiply by SSXY. SSXY is that. So that's the sum of squares regression. Now SSE then can be computed as the difference between the two. SST minus SSR will give you SSE. Now the regression degrees of freedom is equal to the number of x variables in the equation. In simple regression it is always 1. There is only one x, so 1. So then we can take the difference between the degrees of freedom for total and the degrees of freedom for regression, and you get the SSE value. So now R squared then is SSR divided by SST, and we can express that as a percentage. So we can interpret this value as the proportion of variance present in the y values, which in our case is sales. So 84.79% or 84.8%, let's keep one decimal place. So 84.8% of the variance present in annual sales is explained by the regression between annual sales and number of customers within 30 minutes.